Hello! In this video I want to share some tricks for quick area counting. By the end of this video you'll be able to look at a position like this one and very quickly tell who is winning and by how much. Depending where you're from, where you've been playing, you might be more or less familiar with the idea of area scoring. So I'm going to start with a quick comparison between area scoring and territory scoring, the two major different scoring methods in Go. You can see here a list of what some of the main rule sets use. But even if you've been playing with, let's say, the Japanese rules your whole life, you probably encountered the Chinese rules sometimes if you're playing, let's say, online on the FoxGo server or the GoQuest Go server or something like this. Or perhaps you traveled to another country to play and there you played with area scoring rules. So as a Go player, it's very good to be aware of the two different scoring methods and the differences between them. So I'm just going to do a quick example. We're not going to go into details here. That's not the main topic of this video, but we're going to score this little example position here using first territory scoring and then area scoring. So in territory scoring, you get points for your territory, hence the name, and also captured stones. And in that we include both prisoners off the board and dead stones on the board. So when counting in our head during the game, we would do this just by counting dead stones twice, once for the territory underneath the stone, and a second time for the extra point we get for the stone. So I would count for black here, 1, 2, 3, 4, 5, 6 points. And white will get 1, 2, 3, 4, 5, so black is winning by 1 point in this case. When we score the same position by area scoring, we don't care about what's inside here. Are there black stones, white stones, empty spaces? We just look at the whole area that is controlled by black and the whole area that is controlled by white. And we count the size of this area. We see that the size of the black area is 13 squares. To count it quickly, you may notice that this is a 2 by 5 rectangle and then 3 extra. And white has 12 points. A 2 by 5 rectangle with 2 extra. Okay, so black wins by 1 point again. In this case, territory scoring and area scoring gave the same result. Both say that black is winning by 1 point. And this is true in general if the same number of black and white stones was played during the game. So they could differ by 1 point if black made the last move. Then because this move, the stone on the board is worth a point under area scoring, this would mean an extra point under area scoring, but not an extra point under territory scoring. So it's common that they differ by 1 point, but usually not by more than that. There can be bigger differences between rule sets depending on how sec is counted, so on. That's also outside the scope of this video. Let's just focus on these basics for now. So they basically give the same result. What are the pros and cons of counting in both ways? Which is easier to count? Well, with territory scoring, we only need to count empty spaces and prisoners. We can ignore all the live stones. It doesn't matter how many live stones on the board. And that's nice because in a big game there can be lots of alive stones. So it's nice to save all that time. With area scoring, it seems like we need to count everything. But the upside here is that each point is owned by either black or white. So we can actually just count one of the sides. We can count either the black area or the white area, and then we can check, is this more or less than half of the board? In this case, black has 13 area, that's more than half of 25, so black is winning. And we don't even need to check the white area to know that black is winning. So this is the big upside of area scoring. Now this assumption here that each point belongs to either black or white, it can break down in at least 2 ways. First of all, we could have a seki at the end of the game, and then we could have a neutral point that neither side owns. This is easily fixed by just sort of pretending that both sides get half a point for each neutral point in a seki. Then it's still true that we are dividing up a total of 25 area among the players, and we can still use the same half-board trick. So that's not a big problem. A bigger problem is if we're, let's say, in the mid-game on the big board, and there are big undecided areas. Then this half-board trick is basically entirely useless, and we're not going to get any savings from that. So in those cases, territory scoring is definitely superior. So even if you're playing under area scoring rule sets, you will usually count territory in this way during the game when you want to estimate the size of the territory. But this video will be focused on this half-board trick and cases where this can be useful during the game. And this is mainly going to happen on the 9x9 board. There's one more little wrinkle in this half-board idea, which is, what about Comey? Because obviously, black having half the board is not going to be enough if white also has some Comey. So let's look at some numbers, what happens when we give white different amount of Comey. To just give an example calculation first, let's start with 0 Comey on the 9x9 board now, and see that the total points available are of course 81, 9x9. And if we divide this number in half, we get 40.5, and that's the number of points that black would need to draw. It's also the number of points that white would need to draw. If you have more than this number, it's a win. If you have less than this number, it's a loss. If you have exactly this number, it's a draw. You might think, oh, you can't have half a point, but again, you could if you had a Seki on the board and you give half a point for each neutral point in a Seki. So that's a 0 Comey case. Now, if we add some Comey, let's say 7 Comey, because then that makes the numbers easier. Then now the total points available is 88. We add 7 to this 81 number. So this is sort of the total size of the pie that we're dividing up among the players. And dividing this by 2, we see that now black needs 44 points to draw. More than 44 wins, less than 44 loses. White already has 7 points in the bag from the Comey, so white only needs 37 points on the board to secure the draw. More than 37 wins, less than 37 loses. Then it's the same idea for 5.5 Comey, 7.5 Comey. The numbers change only slightly. You would still have that, let's say, 36 point for white would still be a loss in all these cases, and 38 points for white would still be a win in all these cases. The only difference is if white has exactly 37, then with 7 points Comey, that's a draw. With 5.5, it's a loss. And with 7.5, it's a win for white. So very minor differences between the different Comey values. We're going to be sticking to this 7-point Comey for the rest of the video, but if you're playing somewhere which uses a different Comey, the adjustments you need to make are really small. I'll also quickly show here the same table for 19x19, just if you're curious. Precisely the same idea. Let's do the last column here. So we add 7.5 to 361. This is the total points available. We divide that by 2. That's how much area black needs to win on the board. And then we subtract away the Comey. That's how much points white needs to draw. You might also notice here, I'll take this opportunity to notice that the difference between this number here, how much does white need to draw without Comey, and how much does white need to draw with 7.5 Comey, is 3.75. So this is the reason why if you've been playing on a Chinese Go server like the Fox Go server, and you've seen the Comey represented as 3 3/4 stones, this is where that number comes from. It's half the size of the Comey. So that's where the 3 3/4 come from. Okay, so now we'll look at some example shapes on 9x9. We're going to stick to the 7 Comey. So the magic number is white needs 37 area to draw. We're focusing on white. We could also be counting the area for black, but it's normally going to be easier to count a smaller area. So since white needs a smaller area to win, and white is normally going to have a smaller area on the board, we're going to focus on the white side. And we'll start with some very artificial shapes here. You'd never see a shape like this in a real game, but it's just a starting point, and then we will use these to compare to real game positions later. So the simplest possible board division, we just have a straight line from top to bottom like this, and we see that black has 5 columns of points, white has 4 columns of points. A couple of different ways of thinking about how to count this. We could first just count the size of both areas. So black has 5 by 9 is 45, white has 4 by 9 is 36. We add the 7-point Komi, that gets us to 43 for white, 45 for black. Black is winning by 2 points. Okay, that's one way of doing it. But we have this shortcut now that we know that white needs 37 points on the board to secure the draw. And in this case, 4 by 9 is just 36, so we see that white does not have enough to secure the draw. This must be a loss for white. So this is a black win. If we change just one of the black stones to white, we increase the size of the white area by 1, we decrease the size of the black area by 1, and this will now be a draw. White has exactly 37 points area, and we notice that even though over here this was a black win by 2 points, we just changed one stone and it changed into a draw. So we sort of moved the score margin in a step of 2 points. And this happens because, like I just said, we increased the area of white by 1, we at the same time decreased the black area by 1. So in general you always get these steps of 2. So this is a black win by 2 stones, but it's kind of the smallest possible margin. So we can also call it a black win by 1 stone. And here, when white gains 1 extra stone on the board, then it's a draw. And if white gets 1 more stone, then it's a white win by 1 stone or 2 points. So we have these 2 different scales. It can get a little bit confusing, but I'm going to be using both scales so you can look at the one you prefer. We count either in points, which is what maybe you're used to if you've been using a territory scoring rule set, or we're counting stones, which is more natural when we're only counting one side. So we can do the same idea. Instead of dividing the board along a straight line, we do a diagonal line. The size of the areas is still the same. White still has 36 here, and that's because, just like in the last shape, the sort of extra stones black has are these 9 along the center line. So this is still a white loss by 1 stone or 2 points. And if we give white 1 extra stone along the edge, then it's a draw. If we give white 2 extra stones along the edge, then it's a white win. In these examples, I didn't bother making the number of black and white stones the same, so if you count these using territory, you would now not get the same results. But don't worry about that, we're thinking about area for now. And the last shape I want to show is the square. So another easy way to make 36 points is to make a 6 by 6 square. And again, this will be not enough for white to secure the draw. White needs 37 to secure the draw, so we need to add 1 stone past this border to get the draw, and 2 stones past this border to get the win for white. Now, all of these shapes are very artificial, but when we have a real game shape, we can move some stones around to get a shape which matches one of these. So we're going to look at 10 real games from the GoQuest server. The GoQuest server uses Chinese rules and with a Komi of exactly 7 points. So all the math we just did applies. White needs exactly 37 area to draw. I didn't really handpick these games to make them good for these tricks. I just went on GoQuest, picked like the 10 first games that went to scoring or were somewhat close. So you'll see, especially in the later examples, some games where the trick doesn't work that well. But we'll start from some ones where the board is very clearly divided in 2 halves, and we can apply the trick really easily. So here is the first game. We can see that the board is basically divided in 2. We have this line going somewhere along here. It's a little bit jagged, this line, but we don't really worry about that. We still just draw this straight line where black has 5 rows of territory, white has 4 rows of territory, as in our previous shape, just rotated. And then we're just going to count how much is black going past the border and how much is white going past the border. And by comparing those numbers, we can figure out how much white is winning by or how much black is winning by. So maybe one easy way to start by is by picturing moving this white stone up into this black space here, and moving this white stone up into this black space here. Then white would be 2 stones past the border, and as we saw before, that's a white win, when white is 2 stones past the border. Maybe more in general, we wouldn't need to think about moving the stones, we could just count. Black has 2 stones passed, white has 4 stones passed. That's the same as white being 2 stones passed, and that's the white win. So it's a white win by 1 stone or 2 points. And again, the reason it's a white win by 1 stone is that white needs 1 stone past the border to secure the draw. So 2 stones past the border is like 1 extra stone. The margin of victory is 1 stone, and number of points is always twice the number of stones. So here's another example position. You can now think for yourself, pause the video here, where would you draw a line, and how many stones are past the border, and based on that, is it a white win, a black win, or a draw? This is a good candidate for drawing a diagonal line. So we draw this diagonal, we count that white has 1, 2, 3, 4, 5 stones past the border, black only has 2 stones past the border, so this is a white win. And if we want to be more particular, we count that, okay, 5 minus 2 is 3, white needs 1 extra to draw, so that's 2 more than the margin, so it's a white win by 2 points or 4 stones. I know that gets very confusing, but getting the exact margin is not so important. It's enough to just say, okay, white is winning. The confusing part there is like that extra 1 across the border. It would be much easier if the komi was 9 points, then our lives would be very easier. But unfortunately it's not, so we have to deal with that sort of off by 1 error all the time. Okay, third example. You know the drill, pause the video, try to figure out the count. Here I would say there are 2 good choices for the line. We could draw this diagonal line, would be a good choice, or we could draw this straight line. And I chose the straight line in this case because usually it's a little bit easier to picture the straight line, especially when you don't have the visual aid of like drawing it on the board like I'm doing now. When you're doing it in your head, I would say the straight line is easier to work with. So we count 3 stones passed for black and 7 stones passed for white. Again, in a real game, if you're actually at the board doing this counting, you can stop here, you know. You don't need to worry so much about the exact margin. You just see that white has more than black by a large margin. Easy win for white. No need to think further. But if we want to do the exact counting, we see, okay, 3 here, 7 here, that's 4 extra for white. That's a 3 stones margin or 6 points for white. Okay, I'm gonna start going a bit more quickly through the other examples. Pause the video here. This time we get to use the square. So we can place this square and we can move these 3 white stones here up here. There's 1 white stone here, and we see that white is not able to fill up the square. White is missing 1 stone, and white would need to go 1 stone past the border to get even a draw. So this is actually a white loss by 2 stones or 4 points. Again, we could do this either with a straight line or with a diagonal. I chose to do it with this diagonal. So then we have 4 white stones across the border. And for the black stones, we need to be a little bit careful. We need to count 1, 2, 3, 4, 5. And then also this here. This is also a part of the black area. So it's actually 6 black stones, or sort of 6 black area past the border. Black had 2 more than white. That's a margin of 3. So it's a black plus 3 stones or 6 points. Again, in an actual game, you would just say black has more than white, black win. You can stop there. Here we again draw a straight line. 7 passed for black. We have 9 passed for white. That's a white win by 1 stone or 2 points. And we reached the position from the thumbnail and from the first slide. So now is the time to check how quickly can you do this one with what you learned. Again, we draw a straight line. We count 7 white stones here, 5 black stones here. It's a white win by 1 point or 1 stone or 2 points. And now let's make it a little bit harder. So far, the example positions have been very easily divided in just 2 regions, either a straight line or a diagonal line. But something that's also common in a 9x9 game is to have these kind of games where the board is sort of divided into 4 corners. And then it can be much harder to apply these tricks, but it's still possible sometimes. So what you could do in this case is you could picture these rectangles. You try to fit some rectangles which are mostly white stones, but maybe not quite. And then you can move the white stones that are outside the rectangles inside the rectangles. I move these 2 here inside this, and these 3 white stones here I move inside these spaces here. I will be able to completely fill these rectangles, and in the lower right corner we have 20, 4x5, here we have 16, 4x4, so that's 36 points. That's not enough to win for white, so this is a black win by 1 stone or 2 points. We could also, if we wish, imagine this sliding over to the right here and creating this shape we're used to of just 4 columns. So this is a little bit more advanced. We're stretching the sort of usefulness of our trick. Like you might start to say here, wouldn't it be easier to just count the points the sort of normal way? But let's just try to apply this one more time. So in this next position, can you do the same thing? Can you make some rectangles and count the area in this way? So here's one way of doing it. We create these rectangles, we move these 2 stones up here and these 3 stones into these spaces. We get 20 points here, 18 points here, 38 points in total. That's 1 more than white needs to draw, so it's a white win by 1 stone or 2 points. And one final one. How would you count this position? If we want to do this by area, I think the easiest way I can come up with doing it is by drawing this line here and just sort of picturing these stones sort of falling down to fill this hole here, right? So we have, in this space, if you count them up, you have 13 black stones, 13 black area, and we have 13 white area up here, so we can just fill this black area with these white stones. We have 1 white stone here, which can fill this hole. So this is actually exactly 36 white area, so it's a black win by 1 stone or 2 points. Now, it's not too hard to verify that what I just said is true, that you can quickly move some stones to get like 12 plus 1 in these regions, so it's not hard to verify. But if you're actually trying to do this in the game, you know, you're trying to get something like this work and it doesn't quite add up, you get lots of leftover stones to keep track of in your head. So I'm not saying this is the best way to count this position. In a position like this, I would just recommend using the regular territory counting. And the way I would do that is I would count the territory in pairs. So I would say for white here, instead of counting 1, 2, 3, 4 points, I would just say 1 pair, 2 pairs, 3, 4, 5, 6 and a half. When we get to a single point, which we can probably need to say a half, 6 and a half. Komi is 7 points, that's 3.5 pairs. So that's 10 points in total for white, 10 pairs in total for white. And then we count black, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So black has 11 pairs, white has 10 pairs, that's a win by 2 points for black. So this way you can also get very quick at with some practice. And I would say this is more flexible than the area counting. You're not relying on some particular shape, you can just start counting the points. So I just wanted to end on this note about like, this is limited in usefulness, these tricks. It's mostly for when the board is simply divided in half. In other cases, I would recommend territory counting. And we could say more generally, when is this useful, the tricks we talked about? Well, we only looked at finished game positions so far. And if you think about it, there's really no point in counting a finished game position unless we're actually like determining the result, for which you normally just move the stones around physically. So the point of doing this quickly for finished game positions is that if you're not actually at the end of the game, but you're, let's say, 5 or 10 moves earlier in the game, but you can read to the end of the game, you can read one variation to the end of the game, and you want to check, is this variation winning for me or not? So normally this would be something like, I can go for a very simple line where we just divide the board in half, and you want to check, is that enough for me to win, or do I need to complicate things? Do I need to start this code, try this invasion? These are the cases where it's useful to be able to quickly count a position you just have in your head of what the finished board could look like. And if the board is just divided in half, this might be very easy to do. But if you don't have this kind of easy to divide in half shape, even if you get a finished board, it's not going to be that useful to do the area counting. You can just do the territory counting. So in particular, the second condition here, having an easy to count shape, it happens a lot on 9x9, but basically never on 19x19. You would never see a 19x19 game where the players just nicely make a straight line across the board and they get 1/2 each. So everything we talked about, this can help you on 9x9 sometimes, but it can basically never help you on 19x19. So if you want to apply what you learn, go play some games on GoQuest or some other server. It doesn't really matter, even if you're playing with territory scoring, you could still kind of apply the tricks. Like I said, the differences are like plus minus one point or so. It's not that important. If you're getting a win by several points, like it's going to be the same across the rule sets. But if you're playing on GoQuest or the FoxGo server, you're going to be using area scoring, and then you can really apply these tricks exactly like we've explained them. That's it for this video. Hope you found it useful, or at the very least interesting. Thanks for watching, and see you in the next one.